am I? I am Dale Gnidovec, curator of the Orton Geological Museum. Now, I've dug dinosaurs all over the West. I've loved dinosaurs since I was a little kid. I grew up in the Cleveland area, and every year my folks would say, "What do you want to do special for your birthday?" They knew the answer. Take me to the Cleveland Museum so I could see the dinosaurs. So every year we'd drive to Cleveland so I could see the dinosaurs. I volunteered at the Cleveland Museum as a high school student and just fell in love with museums. I've been lucky. I've worked in museums most of my professional career. But today I'm going to talk about Jurassic Park, the movies. So welcome to Jurassic Park. The first movie was almost a religious experience for me. I loved it when the brachiosaurs reared up to get the leaves in the tree. After that, they just sort of went downhill. It just became monster movies with the dinosaurs as the monsters. So I'm going to concentrate on the first few films. I'm not going to talk about DNA and whether that's feasible. DNA is a very fragile molecule. It's long and skinny like a thread. I just don't see it preserving for over 60 million years. They might pull it off with a mammoth, but those have been extinct for only a few thousand years, not tens of millions of years. Now, the world's been around for a long time, and it's sort of kept a diary of what's happened to it. Each layer of rock is like a page in that diary. And geologists have taken this whole history of the Earth and divided it into smaller parts. The Jurassic period was in the middle of what's called the Mesozoic era. It was discovered by this gentleman, Alexander Humboldt, and he named the rocks for rocks he saw in the Jura Mountains on the French-Swiss border. But the Jurassic is only one period in the Mesozoic, which is called the Age of Dinosaurs. So there was the Triassic before it and the Cretaceous after it. And if you look at most of the major prehistoric players in the first few movies, they're actually from the Cretaceous period. So this set of films should have been called the Cretaceous Park. If we look at Tyrannosaurus and Triceratops, they are found in a rock unit called the Hell Creek Formation. I spent 3 summers in the Hell Creek, and everywhere you look, there's evidence of water. Here's some sandstone with these cross beds that indicate flowing water, ripple marks in mud that indicate flowing water. Everything suggests that these animals preferred very wet environments. On the other hand, if you look at the sauropods, the big brontosaur types, everything we know about them suggests they lived in a very warm environment that was dry. They're most famous from the Morrison Formation. I spent parts of 13 summers digging into the Morrison Formation. Everything indicates it was very dry, almost like this, maybe a little drier. The only real wetlands were right along the river valleys. The original island was only supposed to be a few square miles. It doesn't seem possible to me to have enough wide open dry area for the big brontosaur types and enough land area for the wet-loving dinosaurs like Tyrannosaurus and Triceratops. Amber is very crucial to the story of the movie. What is amber? Amber is often called petrified sap. It's not sap. Sap is water soluble. Amber is petrified resin, the sticky stuff that comes out of a pine tree when you cut off the bottom for a Christmas tree. And amber can preserve things very well. We not only get bugs in it, we can also get leaves and twigs and feathers and even small animals like frogs and small lizards. But the amber used in the movie was Dominican amber. And Dominican amber formed long after the dinosaurs. In fact, missed the dinosaurs by over 41 million years. The scene where they had the scientists just brushing off the sand off the fossil bones. When they first saw that, every paleontologist in the world went, "Ah, come on! It's not that easy." Digging dinosaurs is essentially chiseling them out of solid rock. We use hammers and chisels. Sometimes we need jackhammers and power equipment, so we still have to chisel them out of solid rock. Also, the movie showed them sending sound waves down in the ground and getting a nice picture of the buried skeleton. Paleontologists had high hopes that the technology would advance that far. It's been 30 years and it hasn't happened yet. We've tried ground-penetrating radar. That works good in soil, doesn't work well in rocks. And we also tried sound waves, acoustic tomography. In the movie, they fired gun shells into the ground. Here, you're beating on a metal plate. But there's a good reason that hasn't worked. Dinosaur bones are petrified. That means they've been turned into rock. So you've got a rock, the bone, inside rock. There's not enough difference. Dilophosaurus. This is a much better picture of what that animal probably looked like. Notice there's no frill on the neck, and there's no evidence that this dinosaur or any other dinosaur was poisonous. But especially this one. That animal had a mouthful of sharp teeth, big claws on its hands, and big claws on its feet. Was that animal that needed poison? I don't think so. Velociraptor, the villains in the movie. There was a real velociraptor, but the movie made it much bigger. Actually, the movie Velociraptor was based on another animal in the same family, Deinonychus. Real Velociraptor is only about as tall as a human's waist, but Deinonychus was the right size for the movie. It had the same killer claw on the foot and probably similar disposition. But how do we know they were intelligent enough to hunt in packs? We can look at the size of the brain and compare the weight of the brain to the weight of the body. But you can't just look at the brain by itself. So now we've got the weight of the dinosaur. We need something to compare it to. And in this study, the animal they compared it to was a lizard. That is, they took the weight of the brain, compared it to the weight of the body, and made that ratio 1. 1 unit of intelligence. Let's do the same measurement for dinosaurs. The sauropods, these are the big brontosaur types, 0.2. Sauropods were just plain dim. On the other hand, looking to the coelurosaurs, these are the small two-legged dinosaurs like Velociraptor, 5.8. More times brain power than a lizard. That's getting pretty high. That's getting in the size of modern day birds such as crows and parrots, which are very intelligent animals. One of the classic scenes was showing the brachiosaurus there with its head up in the trees chewing like a cow.
Just think of it as kind of a big cow.
There's no way it could have done that. Look at those teeth. If those teeth tried to chew side to side like a cow, they would break off. Sauropods didn't chew. They would just grab the foliage and strip it off. Grab it and strip it off. Another group of animals shown in there were the pterosaurs, sort of cousins of the dinosaurs. We know about 200 species. They ranged in size from sparrow size up to huge. One in the movie was obviously based on this one, Pteranodon, best known from the Cretaceous chalk beds out in western Kansas. 1,000 specimens of these have been found. It had a wingspan of about 25 feet, and we estimate its weight at about 100 pounds. Trouble is, a 100-pound flying animal is not going to have the list to carry off a 150-pound person. Just ain't going to happen. Also, if you look at how pterosaurs walked, they walked on the flats of their feet, like we do. Ever try and pick up a pencil with your toes? They just didn't have grasping toes. So the idea of pterosaurs carrying off humans is just not going to work. The velociraptors also were shown with these hands that curved downward. Dinosaurs couldn't do that. If you look at the bones in your lower arm, you've got 2 bones. The bone that runs from your elbow joint down to your thumb side of your wrist is called the radius. The bone that runs from your elbow down to the pinky side of your wrist is called the ulna. Dinosaurs have the same thing. For you to turn your hands over one of those bones, the radius, has to go over the ulna, and dinosaurs couldn't do that. So, dinosaurs could not play the piano. Anytime you see a carnivorous dinosaurs with the palms facing inward, that's correct. If you see them facing downward, that's incorrect. How about feathers? Feathers have been found for sure in over 50 kinds of dinosaur, and we know that the raptors had them, although the movie showed them with naked skin, scaly skin. We know Velociraptor was feathered. The upper arm bone there is the bone of a bird. It's the ulna. And notice it's got those bumps along it. Those bumps are where the big feathers attach. Velociraptor had those bumps. So Velociraptor was feathered. How about if you didn't move Tyrannosaurus wouldn't see.
Don't move a muscle!
Total Hollywood. There's nothing even remotely related to the dinosaurs whose vision operated on that kind of principle. Plus, Tyrannosaurus had eyes that were the size of baseballs. Right? The bigger the eyeball, the more light you get in, the better you can see. It's even been suggested that Tyrannosaurus was a night hunter. Looking at the brain, it had a huge olfactory bulb. Tyrannosaurus probably had one of the best senses of smell to ever appear on our planet. So if it couldn't see you, it could certainly smell you. How about chasing a jeep? Biologists have a pretty good handle on how much force it takes to move an animal and how much force that those bones can take before they break. Tyrannosaurus' weight is estimated pretty closely at about 7 tons. Now, the force on that leg is tremendous. Look at how small that leg bone is. Look at the skeleton there. Force is mass times velocity squared. So the faster you're going, the more stress you're putting on that leg bone. If you try to get something weighing 7 tons going fast enough to chase a jeep, you would shatter those thin lower leg bones. Also, what's powering this animal? What's the engine? The engine are the back leg muscles. It takes more power to move a dump truck than to move a Volkswagen. To get something weighing 7 tons up to speed to chase a jeep, you're talking about a huge amount of leg muscles. More than half the body weight. That's not a workable animal. We think the maximum speed of a T-Rex was probably around 15 miles an hour. Now that's faster than I can run, but I don't go chasing jeeps. How about ripping through a car? You can take any skull, a modern day skull, a prehistoric skull, and analyze it like you would analyze a machine. In this case, a crushing machine. And when you do that, we can calculate how strong the bite force was. And compared to modern day animals whose bite force has been measured, T-Rex had a bite force of almost 8,000 pounds. So yes, it could have crunched through cars without a lot of problem. The movie had T-Rex's diet supplemented by a lawyer. And shortly after that movie appeared, 2 colleagues of mine produced a study where they counted how many lawyers it would take to feed a T-Rex. They calculated how many calories in a lawyer and how many it would take to feed a T-Rex. And they calculated it would take about 73 lawyers a year to keep an adult T-Rex going. That was back when we thought that all dinosaurs were cold-blooded. The reason for that is dinosaurs are reptiles, and all modern-day reptiles are cold-blooded: snakes, lizards, turtles, and crocodiles. Since then, a lot of evidence has been produced to show that dinosaurs were almost certainly warm-blooded. Why is that important? If it took 73 lawyers a year to feed an adult T-Rex that was cold-blooded, it would take 730 lawyers a year to feed a T-Rex that was warm-blooded. That's a quick run at some of the things that they got right and some of the things they got wrong.
The terror, the Jurassic time.